In today's session, we are going to discuss about that is engineering geology. We specifically going to discuss about dams. So, what are the major geological parameters we have to consider while selecting this location or the site for a dam construction? So, for example, if you see the image which is there on the screen, the amount of water or the amount of energy stored under this on this dam site is very huge. So any failure on to this structure is going to be a very devastating effect on the nature, and it is human life loss, and there are so many other related issues which are going to result in the failure of a structure, basically a dam structure. Here we are going to see that what kind of geological parameters, because the design is there with the hands of a civil engineer, but the natural processes or the natural conditions existing on the site is not in hands of a human. So we have to select a site appropriate for the construction of a dam. So before going into the details of the site selection, what is a dam? A dam is basically a solid barrier which is constructing across the river valley. The purpose of the dam is to stop the water, impounding the water. So the water which is stored under this dam, the upstream side of the dam, we call it as a reservoir. And there are different purposes for which we construct the dam. It may be for hydropower energy, or it may be for an irrigation purpose, or it may be for any domestic water supply, for controlling the flood, for navigation. So there are a number of different purposes the dams are constructing. What you are seeing on the screen is a dam which is constructed across the river for a hydroelectric project. This is basically from Parvati project, which is there near Manali. So the water which is going to store in the upstream of this particular dam is going to be used for the generation of electricity using by a hydropower project. Okay, so before going into the specific details of geology, there is a requirement of basic idea about a different type of dams and what are the different processes which are acting on the dam. So if you see the dam that I already discussed, it is a solid barrier which is constructing across a valley to impound water. So there are the dams can be classified into different types. Basically, if you see the first, the classification is based on a design. So the dams are of a gravity dam, arch dam, buttress dam. So these are basically the design of the dam. That what kind of design is used for the construction of the dam. Or in other way, if you say that where exactly the load from the dam is transferring to, whether it is transferring to the foundation of the dam or it is transferring to the sides or the sides of the valley. So that is based on the design. Then second one, if you see that it is the based on the material, it can be of a concrete dam where concrete is extensively used for the construction of the dam, or rock fill dam, or an earth dam where the materials like soil, gravel, sand, and other materials are being used to construct the dam. And the third one, it is the size of the dam. It can be a small size dam or it can be a large size dam. So these are basically the classifications of dam or the type of dams commonly you will be seeing in the textbook or in the reports of geological studies of dam sites. So next is we are going to briefly discuss. I'm not going to discuss about all the different varieties of dams because that doesn't come under our purview at this point. Rather, you will be studying in detail about this different dams design and other parameters in your higher semesters. But at this moment, where we are going to discuss about the construction of a dam and its geological characteristics, there is a requirement of a basic idea about the dam characteristics. So for that purpose, we are briefly taking up three different varieties of dams and how the forces and how this structure of the dam is going to be considered for a geological site selection. So that is the purpose of discussing the dam here. So first one, it is a gravity dam. When you talk about a gravity dam, this is a gravity dam constructed usually using the concrete structure. It generally being a triangular in shape, and which are designed in that such a way that the weight of the dam is actually taking up entire load. Okay, so the weight of this dam which is constructed across the valley is what which is going to be stopping the water. So the weight is in such a way which is stopping the water, then you can imagine that the rock type which is under this dam should be very strong enough to take all this weight. Because when I say that it is weight which is the which is going to be up act perpendicular vertically downward to the dam orientation, so the soil or the rock should be a strong basement. It should construct so that that can carry all the load from the water. So okay, all forces arising in such a dam is transmitting the foundation rock. That is what the fundamental characteristics of a gravity dam. So these all forces are going to be moving to the downward direction. So if properly designed, they are considered to be the most safer one. Buttress dam is such a type, then concrete slabs is supported from the downstream side. So here in the picture, if you see, this is there are some buttress constructions, concrete constructions, which is supporting the dam from the downstream side. So this kind of dams, which is a particular variety of gravity dam, which have these buttresses to support the dam. Okay, so the upstream surface of the dam may be vertical or inclined. Similarly, the axis may be straight or curved. So here in this picture, you see a straight axis of the dam, but there are chances that the surface maybe the axis may be slightly curved also. So these are different varieties of gravity dams. The only thing, the takeaway point from this gravity dam is that whenever we consider a gravity dam, the forces which is the major force which is resisting the water or storing the water is the weight of the dam, and the weight of the dam is going to be applying vertically downward. So we should get a maximum strength of rock from the basement portion of the dam site. And in other case, if the basement of the rock is not having a strong rock, and in that conditions, and the abutments is the rocks which is present in the both the sides of the dam. So that kind of situations where the rocks are very strong enough, in that kind of situations we may go for an arch dam. So arch dam is nothing but the forces from the water. This is the upstream side and this is the downstream side. The forces which is applying on this dam is directly transferring to the sides of, or the walls of the dam. Okay, so this is the sectional view of the dam. Here is the water level, and this is how the dam is designed. So this is upstream direction, water flows here, and this is the downstream direction. And this is again a cross-sectional view of the dam, where the entire region where we have a rock which is solid, compact and strong, which is present on the sides of the valley, where the valley is narrow, and in that conditions we can design for a arch dam. So arch dam shape, this will be have a, has the term indicate, it should have a shape of an arch, mostly of made up of concrete, because it is going to be a thin layer, thin type of construction, which is basically going to take up the entire load, the water pressure from the upstream direction, and transfer it safely to the sides of the dam. So arch dams are better suited for narrow valley with strong and uniformly dipping walls or abutments. So that is what the best condition. So the basement, if it is not very strong, and the rock types where the base of the valley is not sufficient enough to take the load of a gravity dam, then we can consider, or we can go for a arch dam. Arch dam are thin in walls, so lighter in weight. So that is the characteristics of arch dam. And the third type is a type of dam, that is an earth dam. So earth dams are basically a trapezoidal kind of structure that will be filled with a number of different layers, and it will have a central crust layer, and both the sides on the upstream and downstream side will be filled with a different kind of rock types. So this will act as a in situations where the valley width is very huge, and an earth dam and a gravity dam we are going for, and the concrete dams are not suitable in that kind of conditions, where we will be going for this kind of earth filled dams. And here in this case also we will be expecting that the rocks in the base should be of good character or a good strength, so that the entire material, the weight of entire material and the forces which is going to generated by this dam and the water is filled reservoir can be safely taken by the geological conditions. Now, another primary detail what we will be discussing here, which is the forces which are going to act on the dam. So, as you know that when the water which is flowing on a valley, when we stop that by constructing a dam, so the water which is flowing here, which is going to be stopped by the dam. So the first force which is exerting on this dam, which is going to act on this dam, is its own weight. So the weight of this dam will be acting perpendicular or acting vertically downward. So that is actually the weight of the dam. Now the second thing which is going to act is the amount of pressure which is exerted by the water column. So when I'm saying that is a river, the dam is going to store water. So all this water which is stored in this dam, that will be the reservoir. So that will be exerting pressure on the walls or on the dam. So this is going to be a force which is going to act horizontal. As I said, the gravity will be acting vertical downward, and the weight of the water will be acting horizontally. And if you consider both of these forces, and if you take the vector direction of both of these forces, now if you consider the effective direction of force which is going to act is something of the average of these two directions. So something like this. This is going to be around angular to the axis of the dam axis of the dam, or the direction of flow direction of the water. So this is the effective force which is going to act on the dam. So there are few more kind of forces. If you consider these two forces, this is the effective forces. Other than that, there are few more forces which are going to act on this. This is the uplift pressure. There is the water which is present in the pores on the rock which below the foundation will be giving the pore water pressures, and these pore water pressures will be converting to an uplift pressure in the case of the construction of dam. Other than that, there are few more different forces which should be taken into consideration. That is earthquake force. You know that as per IS code, we will be taking different parameters for in the case of earthquake forces. And other than that, there are silting, because when the dam is constructed, when water is stored in this reservoir, there is a huge amount of sediments which are going to be deposited in the reservoirs, and the waves which are generating on the reservoir. So that is also need to be taken into consideration, and the freezing of water which is stored in the reservoirs also need to be taken into consideration. Now we will go in detail about the selection of a dam site. When I'm talking about I need to construct a dam across a river. So if I consider the dam or the river, that is Narmada river. Okay, now when you are considering to construct a dam, so there are number of different areas. Okay, I can construct the dam here, I can do it here, I can do it here, or I can do it here, I can do it here. So there are a number of different locations I can consider. So for example, if Gujarat is planning to construct, so our boundary is somewhere here. So this is where the best way to construct somewhere in this. So what parameters needs to be considered while taking this decision? So that is what we are going to discuss here for the first point. So if you see the first point, what I have written here, that is the topography. Topography, what do you mean by the topography? Topography we mean by the surface character, whether it is a undulating surface, or whether it is a plain surface, or whether it is a hilly terrain. So in that kind of topography, we prefer to go for a location where we are getting a very narrow valley, and it is having a wide catchment area. Remember the catchment area. Catchment area is the area. This is not the correct catchment. I have just drawn this for example only. The catchment area means which is the area from which a particular river collects water. For example, if I consider the Narmada river here, the water from this whole region may be contributing to Narmada. But the rainwater which is falling on this particular part, this will be flowing through the Tapi. So this is the drainage boundary. Okay, so that is the terminology we used in the geomorphological portions we discussed, the drainage basin. So the drainage basin of a river is taken into consideration, and the narrow valley we need to take it into consideration. Yeah, this is what I was talking about. Okay, where my cursor right now is the area where we are constructed the Narmada Sardar Sarovar Dam. Okay, so see this how the area is. So the dam is constructed on a hard rock terrain, and just after that it is coming down to the Gujarat alluvial plain. So this location is excellent in point of the number of different parameters, because the construction of the dam is going to be on a hard rock, and there is a sufficient plenty of area which is going to cover, that is the reservoir water is going to rise. So the entire water is going to store in this large valley. Okay, and along with that, technical, constructional, and economical characteristics. Technical characteristics, it is now satisfying here. This rock types are satisfying because the rocks are of basalt. Wrong, they are impermeable. They may have some amount of fractures or joints in it that needs to be treated. Otherwise, that area is good. And constructional materials, because while constructing a dam, you can imagine that the dam requires a huge amount of material, starting from the coarser aggregates to finer aggregates to the water. So because it is on the stream, it is on the river, the water may not be a trouble, but other materials like natural materials like the gravel, sand, cement, and all that things, is the availability is very essential. And in this case, where we were considering about the Narmada, the location was very excellent, because just below, this is the location of dam construction. Just below this part, there are huge amount of deposits of gravels and sand. So the gravels and sand was supposed to transfer from that bed to the dam site. So it was a major benefit of taking this area. Instead of this, if you are doing to construct the dam on this part, so here nearby, if you see, nowhere we have an availability of sand. All this area is exposed to hard rock. So there is no availability of sand or gravels. So if I need to do a construction here, either I need to transport the material, and for the transportation of this material, it is going to be a huge amount of cost involved in it. By considering this location or identifying this location, which is exactly in the junction of this hilly terrain and in the foothill, or in the plain area, we have reduced a lot of cost by getting the immediate availability of materials for the construction. Okay, structurally, this area is safe, rock type is safe, it is having a very sufficient drainage basin, it is a narrow valley, availability of material is good. Then this all parameters is actually going to affect the cost, that how much is going to be we are going to invest in the construction of that dam. Then it comes to be the environmental uh, parameters, because the river which was flowing through this Deccan Trap, and when we were supposed to construct a dam here, there were so many number of different species which was supposed to go underwater by the reservoir. So that has created a lot of trouble during the construction in case of Narmada. And if you remember, or if you have gone through some literature, you may know Narmada Andolan, that was one of the largest public movement against the construction of a dam, and it was not only in Gujarat, it was not only in India, it was all over the world. This point has actually noted. So the amount of number of different species, rare species of animals and plants, and the villages of the peoples who are going to be affected by the construction of this dam was really attracted the attention of so many peoples all around the world, and this has created a lot of trouble during the construction of Narmada Dam. Okay, so these are the basic objectives we have to keep in mind while taking the looking for the site for the construction of a dam. If all these things are even excellent and this is not excellent, then we may not even do to able to construct the dam. Even if I am writing it in the last point, doesn't mean that the environmental aspects are not less important. It is having an equal importance to all other characteristics. Okay, now if I decided to go for the construction, now somewhere in this area I have decided the construction of the dam. Okay, fine. Now what I should go for? So this study I go for, because see, these things are what I am discussing right now here. It is not very much what we call, it is very much not detached to each other. These are all the processes which go together. Okay, so while doing the site location, identifying the location, we may need to do a detailed survey, we need to take some few examples. So yeah, all these processes, the entire process of deciding the site and the planning of the project goes together, and which overlaps in so many places. It is not like that one, the geologist will come and do this study, then the geotechnical engineers will come, then he will do this study. This is not detached that way. It is all going together. Sometimes it may be overlapping. Geologists and geotechnical engineers and the designers and the civil engineers may even work together for the construction of the project. So that way there are a number of processes which goes in hand to hand in the construction, major construction activities. Now, while going for the details of the geological characteristics or the investigation of the sites, we basically go for two kind of studies. The first, we call it as the general geology of the area. So general geology of the area, that means that when we are planning to do a construction or a dam construction on this part, I'm not going to study only this part. I may take a study of a detailed study of the entire drainage basin. Entire drainage basin means the entire area where from the water is contributing to this particular river. So I may study all that entire region or the detailed study of the area. So here when I study this location, that goes into a very detailed study in a high resolution understanding of that location. So these are the two broad areas of the study. So if we go for one by one, general geological characteristics of the area, that comes from this is another river what I'm talking here. There is the Tapi, that is a dam over here. This is the Tapi river. What we see here, there is a dam on Tapi. So while doing that, we may produce number of different geological information, that how this image the area how been derived, what is the characteristics of the soil over here, how much it can erode, what kind of sediments it can contribute, how much may be the siltation on this reservoir, number of different parameters. So this all goes into the general topography of the area, how this area look like, nature of the drainage network, how the rivers are contributing to it, general characteristics of the rock, what kind of rocks are here, whether it is an igneous rock, sedimentary rock, or a metamorphic rock, and the structural characteristics of the area, then the weathering characteristics of the area, how much is the thickness of sediment on the surface which is easily erodable. So that says the weathered profile. So if the thickness of sediment which is easily erodable is more, that means all these things are going to contribute to my dam or the reservoir. So the every year I'm going to get a huge amount of sediment which is going to deposit to the reservoir. So every year I need to remove that, or the water carrying capacity of the reservoir is going to be reduced by this process. So this general characteristics needs to be studied before going for the construction or taking a decision on the construction. Now the second thing, it is okay, so this is again the same thing: topography, drainage network, kind of rocks, kind of material area, what kind of these are all vegetated area. This is again a vegetated area. This is a hard rock surface. So this is a topographically high. This is a highland. So this is all water which is contributing to this river. This is the amount of area. So such kind of different studies is done in the regional geological investigation. Then it goes to the structural characteristics, or sorry, detailed lithological or geological characteristics of the site characteristics. So when you study the site, the first one we look for the what kind of lithology, type of rock, and that makes the area, whether it is an igneous rock or a sedimentary rock or a metamorphic rock. So this thing we will briefly discuss at the coming sessions. We are have a specific session, the relative suitability of different rock type. And I'm straight away going to the second point, that is the structure. Structure we have studied, there are a number of different structures the rock types can show. Either it is an inclined, horizontal, or a dipping, or a faulted region, or a folded region, or a joint, or an unconformity. Number of different varieties of structural features can see in the area. So what I'm going to do here is hypothetically imagining some situations. For example, I'm taking the first characteristics, that is a dip and strike. So dip and strike, if I'm talking about, I have a number of different options. Okay, so an area where the rocks are really horizontal in nature, and I'm going to construct a dam over the horizontally stratified data. Now, if I remember that the forces which are going to act on this, first one, it is the horizontal force which is acted by the pressure of the water. Second one, it is the weight of the dam that is acting perpendicular vertically downward. So the effective direction of the force, effective force would be on angular to these two forces. So this is the direction where the force is going to apply. So as a result, there is a chance of failure of, so these contacts are having going to have a force which is angular to the contact, so there will be a chances of shear failure. Now, if I imagine there is a second condition where the rocks are not horizontal, rather they are all dipping. And this is the flow of water, so the direction of dip of the rock strata are towards the downward direction or the downstream direction. Now, in this case, if I'm going to construct the dam, the same conditions applies here. The force of horizontal force, which is the water pressure, then the weight of the dam, and this is the effective direction of application of force. Now we see that the direction of effective force, which is exactly running parallel to the direction of the joint or the weak plane. So these are called the weak plane. So the force which is going to apply exactly parallel to the direction of the weak or the bedding plane. So this again becomes a not suitable condition, because this may creates a lot of pressure on the rock, and there may be changes which can happen between or across these joints or the contacts. Now the third situation is that the rocks are dipping, but they are dipping on a upward direction. So this is a flow of water, then the rocks are dipping on a upward direction. So this condition, if you go for the best way, if you consider that this is direction, and if you consider the flow of forces acting which is perpendicular to the bedding plane, so this condition we assumes to be the most favorable condition. It doesn't mean that the other conditions what discussed is not to be considered, but if we don't have any other option, we may even consider for that options. But given these three conditions, the last condition seems to be more suitable. So this is why the logical points what we think. That is what the point I wanted to tell you here. And none of this demonstration says that okay, if the beds are downward dipping, we should not consider that location. It is not like that. We may need to even consider that, but giving a proper precautions, we may even consider that locations. Now there is another condition, that is the fault. Fault is a rock, there is a break, and along with there is a displacement. Here if you see, this is the layer across, there is a break and there is a displacement here. The rocks have moved up, and the block above this fault plane has moved down, and below that it is relatively moved up. I don't know which block moved up. This block should have moved down. So this is relatively. What kind of fault we call it is? We call it as a normal fault. So in this normal fault situation, there are three areas I can consider the construction of a dam. This is the first condition, and this is the second condition. This is the location. This is the third location. So in these conditions, the construction of the dam, the first condition, the construction of the dam is going to a footwall. So this seems to be a safe condition, because below that there is the water. But here in this case, what is the trouble is the reservoir is here. It is going to exert a lot of water in this region. So these forces which are exerted by the water pressure may give rise some movement on this block when we consider the area. So there is a change in the relative, because this area is stable, but this area is not that much stable considering the rock type, because the block or the dam is going to be on the footwall. Okay, now the second situation is again the same, that we are going to consider the region which is on the hanging wall. So this again have the same trouble. Will have the same trouble that the huge amount of reservoir and the load which is going to apply on this may give rise some relative movement on this hanging wall, and it may further go down, and thus further going down may trigger some amount of vibrations, and it may even cause earthquakes. So in the second case and the third case, both these things will be considered as a unstable construction, because this is going to be completely on the footwall. But in this case, it seems to be little more convenient in out of these three conditions where we are going to do the construction and the most forces which are going to apply. And you have to keep one thing in mind, even if you are considering that in fault point of view, this bedding plane point of view, this is not a safe construction. Bedding plane is running, or the effective the load or the force is going to be applying parallel to the bedding plane, and that may give rise to some movement along that or the weakness along that. But if you consider these other two things where the forces are running perpendicular to the fault plane, so the forces which is acting on this may be little more suitable. So this is how the reasoning is to be done. What is that is what I'm discussing here. Rather, this is not ideal conditions where we expect in the field. And the third one, in the case of a faulted strata, so the surface is smooth when we see, and below that there are number of fault. And you know that when there is a fault, there are different fault parts. So this we call it as an anticline, this we call it as syncline, this part of the fault we call it as a hinge, this part of the fault we call it as a limb. This is again a limb, this is a hinge portion here. So these are different parts of the faulting. So here also I have three different conditions, and these three different conditions, if we discuss what happens to these three conditions, where in the first case this condition seems to be better because the rocks are dipping on the upward direction of the dam. This is the water flow, this is dipping to perpendicular to the bedding plane, it is dipping, so and the effective force is going to be applicable, and the construction is also going to be at the limb portion of the fault. Whereas if you take this case here, even if the upside, the reservoir part, the rocks are dipping upward, but the dam is placed exactly on a hinge portion of the fault. And what is the character of the hinge? If you remember, when the rock get folded, there would be number of small fractures or weak plane which may be creating on the hinge portion, because that is the area where the maximum deformation happened as a result of folding. So this, even this rock type, all this rock type which is below this part is going to be completely crushed and under high stress. So that is not a very good foundation rock we can consider for the construction of a structure like dam. So this area is highly disturbed, and the rocks may not be having sufficient amount of strength to hold the weight of the dam and the reservoir. So this condition can be taken up as a safer condition, and this can be considered as the worst condition. But in this case, the condition can be intermediate, because here the rock is liquidated in the limb portion, but only trouble is that the downward dipping strata. So if you do proper grouting and the proper locking of the strata, and make sure that there is no amount of movement across that bedding planes, then that situation can be considered as a safer situation for the construction. So similarly, the joints also they make same effects on the construction of a dam. Then this is the second geological characteristics of the site. And while after doing the geological characteristics of the site like lithology, structure and joints, then the engineering properties are going to be characterized in during the rock quality measurements, porosity, permeability, strength parameters, all different varieties of strength parameters. All that things are going to be calculated for that particular site in detail. After doing all these things, a detailed report with all the details of the cross sections, geological details, rock type details, shear strength, structural parameters, drainage basin characteristics, entire things completely, the geologist or the team of geology peoples working in the field will be submitting a report to the site engineer, and then their team will look into that, and accordingly they will design the structure. Now one more thing what we have to discuss here, that it is the rock types. So as from the previous discussions we have made on different varieties of rock types, we know that there are three main varieties of rocks: igneous, sedimentary and metamorphic rock. Now if you ask me that which is the best rock type for the construction of a dam, I will rather say that all three can be considered, but what we have to look into is not the type of rock. What you have to look into is the structure, texture and mineralogical characteristics of the rock that gives the required strength to the rock. What way the rocks are forming is immaterial here, whether it is an igneous rock or whether it is a sedimentary rock or it is a metamorphic rock. So that is not the matter we consider here. What matter we consider here is what is the mineralogy of the rock, what is the texture of the rock, what is the structure seen in the rock, what is the strength parameters of the rock. But what we are discussing generally is a general characteristics of the igneous, sedimentary, and metamorphic rock. For example, if you see the massive igneous rocks such as granite, syenite, and gabbro, they are good. They are good, excellent foundations. So they will have a high compressive strength, high modulus of elasticity, but there may be some secondary structures like the faultings or the joints may create some trouble. Otherwise, they are all good. Granite, cyanide, gabbro, they are all good for the construction. Volcanic igneous rock should be viewed with caution because of the layered form, sedimentary interbeds. Because when there is a volcano which depositing the rocks, so this is a volcano. So there is a flow of flow of magma, and it is creating layers. So the layer stopped here, and after that there is another kind of sedimentary rocks formed. So sedimentary rocks formed, and then there is a continuation of the flow of volcanoes. Then it started continuously forming. So if I see now, when I'm going to consider the construction of a dam here, so when I see on the top, okay, this is the volcanic igneous rock. If I consider that this is safe construction, but immediately below that we have a sedimentary rock that may not have the same strength as of the volcanic rock. So this kind of beds we call it as interclapian beds in the case of Deccan trap eruption. But intervolcanic sedimentary layers are common. So this kind of things needs to be seen or looked in when we see the surface is characterized by volcanic igneous rock. I'm not talking about any other igneous rocks. Specifically in case of volcanic igneous rocks, this sheet nature and the presence of sedimentary layers in between also need to be taken into consideration. Cavities are usually seen in the volcanic igneous rocks because when there is a volcanic rock which form, I have discussed there are vesicular basalt, the amygdaloidal basalts, and all. So these are all the cavities which are seen on the rock. So the bottom portion of the rock may be very massive, but when you see the top of the rock layer, so that may have number of different varieties of this kind of cavities, and that cavities may lead to the failure of the dam or the reservoir by allowing the water to penetrate through that. And the second thing, when we discuss about the sedimentary rock, the sedimentary rocks are massive, well cemented, are generally sound rocks for the construction of a dam. But the limestone we should have to always look into with caution, because limestones, you know that it is very susceptible to the chemical weathering process, and if any water which is having a slight acidity, it interact with its limestone, it can easily leach the limestone, and that can leads to the failure of the structure. Shales are the rocks which are made up of clay sized particles, are usually troublesome because of its specific characteristic. They gradually consolidate and settle down, and the failure of shear failure of the shales is very commonly seen, and it is rapid to deteriorations, and unpredictable elastic constant behavior is also a basic trouble for the case of a shale rocks. Metamorphic rocks are usually, if it is varieties like granite, igneous, quartzites, and marbles are considered to be good, but the volcanic or the metamorphic varieties of shale like schist, plates, and all slate. So these are the rocks which are converting from shale. So the problems what you are observing the shale, that same problems will be seen here also. That may have different consolidations, shear failure, rapid deterioration, and elastic constant, different elastic constant, and predictable elastic constant. So all that problems also will be seen in the case of a metamorphic rock, which are of varieties or derived from the sedimentary shale kind of rocks. So these are the general characteristics of selecting the dam location.